Welcome to Get Your FRQ On. This question is from the 2023 AP Calculus AB exam. It's question 1, and it is calculator active. In the question stem, we have a customer pumping gas into a gas tank. We have a table of values at different times t, and a function which gives us the rate at which gas is being pumped into the tank. Our function f of t is known to be differentiable. In part A of the question, we are asked to interpret the meaning of the integral from 60 to 135 of f of t dt, and to approximate this value using a Wright-Riemann sum. Since f of t is a rate function, the integral from 60 to 135 would indicate the total amount of stuff that changed due to that rate, and in this case it's gas being pumped into a gas tank. So our integral from 60 to 135 of f of t dt would indicate the total number of gallons of gasoline pumped between 60 and 135 seconds. To approximate this using a Wright-Riemann sum, we are looking for the length of an interval times the function value at the right endpoint of the interval. And in order to get points for this response, you should provide a sum of products. So what the readers will be looking for is a sum of products. The factors in each product should be an interval width, in this case 30 seconds for the first one, and a function value for the second factor, so 0.15, plus another width times a function value, plus another width times a function value, and so on. It's calculator active. You can simplify it if you want to. This turns out to be 8.25 gallons, although technically just this response right here would be sufficient. In part B, we are asked if there must be a function value or value of c between 60 and 120 such that the derivative of our function is equal to 0 at that point, and to provide an explanation. First, the setup for this question sounds like a mean value theorem question. And in order to use the mean value theorem, we must know that we're working with a continuous function and differentiable. We know that f is differentiable, that's given, and therefore it must be continuous. All right, so if we have a continuous and differentiable function on our interval from 60 to 120, we need to show somehow that somewhere the average rate of change over this interval is also equal to 0. Which we can do since f of 120 and f of 60 actually have the same value. F of 120 and f of 60 are both 0.1. So if I find the average rate of change over this interval using those two values, we get 0. Since f is continuous and differentiable, there must be a value of c between 120 and 60, where f prime of c is equal to 0. So yes, this c must exist. In part C, we are told that the rate at which the gas is being pumped can be modeled by this function g of t, which is t over 500 times the cosine of t over 120 squared. And given this function, we are asked to find the average rate of flow over the interval from 0 to 150 seconds. All right, well, average value of a function, this is another application of the fundamental theorem of calculus, and we do have a formula for this. We take the length of our interval, we take the reciprocal of that, 1 over 150, and then we calculate the definite integral of g of t dt from 0 to 150. So we have 1 over 150 times the integral from 0 to 150 of this t over 500 times cosine of t over 120 squared dt. But this is a calculator active question. You would not be expected to do this by hand. So because it's calculator active, definitely use your calculator to do this. And when you do, we find that the average rate of flow for our gasoline is 0.096 gallons per second. In part D, we are asked to find the value of g prime of 140 and to explain what it means. Again, it's calculator active. If you've plugged in your g function into your y equals editor on your calculator, most graphing calculators, I would expect all graphing calculators, should have the ability to calculate that derivative automatically. So we can find g prime of 140 using our calculator. It turns out it's negative 0.005. Its meaning, however, since g represents the rate of flow, g prime is a rate of a rate. So we have to make sure that we include this when we explain the meaning. We have to have sort of a double rate interpretation. So at t equals 140, the rate at which gas is being pumped, notice that that explicitly connects our function to g, right? The rate at which gas is being pumped, that's what g illustrates or represents, into the tank is decreasing. So now we have the rate is decreasing, so we have a rate of a rate at a rate of 0.005 gallons per second per second. One of the things that's important about a question like this is account for the negative sign, but only do it once. All right, so because our derivative value is negative, I stated that the rate of gas being pumped was decreasing, and then when I actually gave the numerical part to that answer, I used a positive value because I already accounted for the negative by saying it was decreasing. You could also explain that the rate at which gas is being pumped into the tank is increasing at a rate of negative 0.005 gallons per second, and that would also account for the single negative sign. It's probably a little bit trickier to understand if you phrase it that way, but it should be okay. Usually I like to go with is it increasing or decreasing, and then use a positive rate of change for that and let that dictate whether I choose increasing or decreasing.